Hi everyone, in this video we are going to discuss this example. Okay, so what we have to do using intermediate value theorem, we have to show that there exists a square whose diagonal has length between r and 2r. So r is any real number they have mentioned and we have a square. Okay, we have to prove that there exists a square whose diagonal has length between r and 2r and has area equal to the half of area of a circle having radius r. This thing we have to prove. Okay, so what will I do? I will, first of all we will recall what is formula of area of a circle, what is formula of area of square, and after that using intermediate value theorem we will solve this example. Okay, so let me write here. We know that area of a circle, okay, area of circle is pi r square, where r is a radius of that circle. They have mentioned same circle of radius r, so its area is pi r square. Half of area, that means you will get pi r square by 2. Okay, so let us go for the area of square now, and area of a square I am mentioning here side A is a square. Okay, what will I do? I will draw diagram so you can easily understand. So we are talking about one circle and one square. So r is the radius of that circle, right? And we have a square of side A. So you know that all sides of a square are equal. So A, and each angle is of 90 degree, right? We call it as a diagonal, right? Diagonal of a square. So using Pythagoras theorem, getting this is a right angle triangle, each side of length A, this angle is of 90 degrees. So definitely we can apply Pythagoras theorem, and Pythagoras theorem says, using Pythagoras theorem, you can easily find the length of diagonal is root 2a, right? So we know area of a square is a square. What will I do? I will multiply numerator denominator by 2. So 2a square by 2, right? This 2 means root 2 square a square by 2. So I am doing some small adjustment. 2 means what? Root 2 square, square root will get cancelled and you will get the previous term again. I can write a common square, root 2a whole square by 2. Root 2a whole square, since both of them have a square. So root 2a is length of diagonal. So I can say diagonal square by 2. Getting my point? Diagonal square by 2, since root 2a is a diagonal of that square. So this is, we are familiar with this formula of area of a square, but right now we got one more formula. Area of square can be calculated in this way also, diagonal square divided by 2. So both formulas we are going to use at the end. Okay, so just keep in your mind and then we will go further. Just make a screenshot of it, then I will go further. Okay, so let us move further. So use intermediate value theorem. So we are familiar with the intermediate value theorem. Previous few examples we have already solved in our previous videos using intermediate value theorem. So this theorem is applicable if we have a continuous function on closed interval AB. F of A and f of B should have opposite signs. If one is positive, second one should be negative. If the first is negative, second one should be positive. Then this theorem says there exists a point C between A and B which will give the value 0. F of C will be 0. Okay, so this is intermediate value theorem. So basic thing is we should have some continuous function. So let us define one function now. We define, they have not mentioned any function. So I am defining a function f from r to 2r. So this closed interval I have chosen because they have mentioned there has length between r and 2r. That means the length should lie between r and 2r. So that's why I have selected the same interval 2r as, so I am defining a function in this way, f of x is equal to x square by 2 minus pi r square by 2. See, pi is constant, r is a radius of circle which is constant, 2 is also constant. So this is one constant, getting? X square by 2, it's a polynomial function. So this is a polynomial function, and we know that every polynomial function is always continuous. So that's why this is obviously a continuous function. So let me clearly mention, it is a polynomial function, therefore f is continuous on this interval r comma 2r. So this function f satisfies the very basic condition of intermediate value theorem, that is f is continuous. So let us talk about what are the values of f at point r and 2r. Let us find. Now let us find the value of f at the starting point r. See, I am going to put r here. Tell me what will I get? Replace x by r. So r square by 2 minus pi r square by 2. Tell me, can we take anything common? R square. We can take common. Having same denominator, so that 2 in denominator also we can take common. So r square by 2 common. So only 1 is there, and r square by 2 if you cancel, pi is there, right? So r square by 2, 1 minus. We don't know the exact value of pi, but it is 3.142 something. So 3.142. R square is positive since there is square. 2 is positive, we know. 3.142 is greater than 1. We are subtracting a larger number from smaller one. So obviously it will give us a negative value, right? So here we are getting a negative value. Let me mention. Therefore, f of r less than 0, at point r the function is giving negative value. Okay, please note down this thing, so much important. Let us go find the value of f at 2r. Now f of 2r, so let us put x is equal to 2r here. 2r square by 2 minus pi r square by 2. Let us take separate square. 4r square minus pi r square. Both of them have the same denominator, 2. Tell me now, what can we take common? R square I am taking common. 4 minus pi, right? R square by 2. 4 minus pi means 3.142. See, r square by 2, 101% positive. 4 minus 3 point, okay, so subtracting a smaller one from large number, so obviously we will have a positive value. So therefore f of 2r is greater than 0, right? See, function is continuous on closed interval r comma 2r, giving negative value at first point, that means starting point, and giving positive value at the second point, that means end point. All conditions of intermediate value theorem are satisfied, so that's why we can say, using intermediate value theorem, let me write, therefore by intermediate value theorem, that theorem says there exists some point in this interval, open interval r comma 2r, such that f of c is equal to 0. But see, what is f of c? Let us find. Let us put x is equal to c here. So we will get f of c. C square by 2 minus pi r square by 2 is equal to 0. Okay, some more space is required. Just make a screenshot of it, then I will go further. Okay, so let us solve it further. Let us shift that pi r square by 2 to right hand side. Okay, so c square by 2 is equal to, I am shifting this term to that side, pi r square by 2. See, c square by 2. Okay, already I have told you that if we have a square whose diagonal c, then its area is diagonal square by 2, right? So this is the area of square. So therefore, area of a square with diagonal c. Okay, so if diagonal of square having length c, then its area will be c square by 2. is equal to pi r square. Pi r square means area of a circle. So it is half of, since 1 by 2 is there, so half of area of a square. So in this way we proved as area of a square is equal to half of area of a circle with radius r. So in this way we proved. See, there is one more thing, diagonal has length between r and 2r. So we need to give guarantee that diagonal of that square must be from r to 2r. So here C belongs to this interval, that means 101% diagonal C is greater than r and it is less than 2r. So let me mention, therefore there exists a square whose diagonal has length between r and 2r. Let me mention the reason, because that our C, diagonal C, belongs to that interval r comma 2r, has area equal to half of the area of a circle of radius r. Same statement I have written. Okay, so in this way we solve this example. Just make a screenshot of it, then we will stop. Thank you. See you in next video.